Welcome back everyone to Chapter 4. This time we're in Section 3, the product and quotient rules. As you may have noticed, there are not a whole lot of applications going on, either last section or actually the next few sections. We're going to be learning kind of more the strategy and the tricks in order to calculate out some derivatives. So fewer applications. We'll try to hit a few, but especially in the videos, a lot more definitions and theorems and how to apply these to relatively straightforward math problems. So, here we go. The first theorem we have is the product rule, right? So suppose that we have a product of two functions. So let me pull out my pen here. F times g of x, right? That's the product. We're multiplying things together. And the claim is if you want to take the derivative of a product of two functions, well, it's actually relatively complicated. It goes the derivative of the first, so the first function, f, times the second. Now notice that there's no derivative here, plus the first, now no derivative here, times the derivative of the second. So like I said, this is fairly complicated, right? It is not straightforward like we saw with the sums and the differences and the constant multiples, all that sort of stuff. The product rule is the first really interesting rule here. And so I have a remark to go along with us here. Warning, it's very tempting. We would really hope that you could just distribute this little prime symbol like we've been able to do before, and you'd get f prime of x times g prime of x. And I see this mistake all the time, and the claim is that it's wrong, that this just does not work. And so in order to kind of justify this, in order to show you that this does not work, I've come up with this example here. So I have this function here, x squared. Now, of course, we know what the derivative of x squared is, and we can write it like this if we want, x times x, but the derivative of x squared is 2x, and that's using the power rule. So that's true. However, if you were to try to calculate, if you were trying to distribute this little prime symbol and do the derivative of x times the derivative of x, like I have here, the derivative of x times the derivative of x. Well, the derivative of x, this is a linear function, right? And the slope of x, well, there's a secret 1 right here, right? So the derivative of that is just 1. The derivative of this one, also 1. So 1 times 1 would be 1. So in this case, you would say the derivative is 2x. In this case, you would say the derivative is 1. That makes no sense, right? These are not equal. So therefore, you cannot, not, big red not equal sign, or I guess pink, you cannot just distribute this. You have to use the product rule. All right, so hopefully I've convinced you. Let's actually try practicing with the product rule here. Some examples. So I have this function f, and it is the product of two functions here, and we would like to know how can I take the derivative of this thing, right? Use the product rule to calculate out the derivatives of the following functions. Okay, so now this is where I'm going to use my product rule. So I'm going to say that f prime of x is equal to the derivative of the first, so x plus 2 prime, times the second, and you leave it alone, plus the first, leave it alone, times the derivative of the second, x squared minus 3x plus 5, take the derivative of that. So let's go ahead and calculate these things out. The derivative of x plus 2, well, this is linear. The slope in this linear function is 1. Leave this all alone here, plus x plus 2, leave that one alone, times the derivative of this quadratic. So here I'm going to use the power rule, so this is going to be 2x to the first power, or just 2x. The derivative of negative 3x, well, the slope of that is negative 3, and the derivative of this constant 5 is 0. And there we are. So if I was submitting this as a final answer, I would not spend a lot of time simplifying this stuff down. I would write this one, right, instead of multiplying by 1, just write this out, and then plus x plus 2 times 2x minus 3. I wouldn't even bother distributing that all out or anything like this. This is how I would give my final answer, and this is what I would give 100% credit to. So that's how I would leave the final answer there. All right, let's try it again. So that's the first example of product rule. All right, another product rule. Well, this one's, it's written kind of strange here. We have this binomial here, two terms, squared. But we need to remember that this is the same thing as root t plus t to the 3.2 times root t plus t to the 3.2. Right? So when you say something squared, it's that thing multiplied by itself. Right? So now you really see the product here. So now let's do the product rule, g prime of t. And so I need to take the derivative of the first, leave the second alone, plus the first, times the derivative of the second. Let's evaluate out our derivatives. Now I'm going to try to skip a step here. Let me actually pull off to the side here and just remind ourselves that the square root of t is equal to t to the 1/2. Square root of t is equal to t to the 1/2. So if I wanted to take the derivative of this thing, right, if I wanted to calculate out the derivative of the square root of t, I would use the power rule, right? The 1/2 would come down, and then I'd have t to the negative 1/2, right? You reduce your power by 1. So this is our n, t to the n minus 1. So I'm using the power rule. All right, now let's bring it back, and we're going to use that several times here. So I'm going to take the derivative of the square root of t. So that's going to be 1/2 t to the negative 1/2 plus the derivative of t to the 3.2. So a 3.2 comes down, and I reduce my power by 1. So I have t to the 2.2. Leave that second alone there. So root t plus t to the 3.2 plus root t plus t to the 3.2. So far so good. We're leaving that one alone. And now we take the derivative of this. And notice this is the exact same as we had over here. So it's going to be 1/2 t to the negative 1/2 plus 3.2 t to the 2.2. And now one thing that you can notice is that this and this are the same, and this are the same, and since we can multiply in any order here, these two terms are the exact same, which is very nice. So this is really, since we're adding them together, there's really two of them, right? So 2, and then I would write this 1/2 t to the negative 1/2, right? I'm just copying down now, 3.2 t to the 2.2 times root t plus t to the 3.2, right? And so that is how I would leave my final answer, right there. Okay, so there is the derivative of a different product of functions, right? One that looks like it was squared. All right, one more example, then we'll leave the product rule alone for a little bit. This one's interesting because I have really the product of 3 functions. So the question is, how on earth do I do this? And the claim is, well, you're going to do it one at a time, essentially. So I'm going to take this. I don't know what that was. So I'm going to take this here, and I'm going to think about it as if this was x plus 1. That's going to be my first function. And then my second function is going to be x plus 2 times x plus 3. So I'm going to do a little bit of grouping here. So now when I go to apply the product rule, h prime of x, I'm going to do the derivative of the first. And I'm going to start doing this a little bit faster. This is okay for quizzes and exams, for showing your work. I'm going to start doing these things a little bit faster, right? Instead of just writing out x plus 1 prime, well, we know what the derivative is, right? The derivative of x plus 1 is just 1, right? This is a linear function. The slope of it is 1. So the derivative of the first times the second. So we're leaving this alone. Plus the first, leave it alone, times the derivative of the second. And now at this point right here, this is where I'm going to use the product rule again. So I'm going to kind of pull it off to the side here and try to figure out what is the derivative of x plus 2 times x plus 3. And in order to do that, I'm going to use the product rule. So it's going to be the derivative of the first. So the derivative of the first is 1 times the second, x plus 3, plus the first, x plus 2, times the derivative of the second. The derivative of the second is again 1. right? Because the slope here for this linear function is 1. So this is going to be x plus 3 plus x plus 2. This one I can simplify down, right? This is going to be 2x plus 5 if you'd like. So that's what the derivative of this is. Now I'm going to plug this back into my function up here. So 1 times anything, that's just going to be the anything here, the x plus 2 times x plus 3 plus x plus 2. And instead of this derivative right here, we now know that that derivative is the same thing as 2x plus 5. So 2x plus 5. Again, I would not spend a lot of time simplifying this down. I would just say, here is my final answer. Right? I know we can FOIL this out and get a nice looking quadratic, but that's a fine way to leave your final answer. I'd give 100% for that. Okay, that's the end of the product rule. That's half the video right there, half of the section. The other thing, the quotient rule, right? So the section's called the product rule and the quotient rule. So here we go, the quotient rule. Again, just like before, the product rule is not so easy. The quotient rule is also not so easy. So the way that we take the derivative of a quotient of two functions is it's going to be the derivative of the top times the bottom minus the top, leave it alone, times the derivative of the bottom, all divided by the bottom squared. So bottom function squared. So this is even more complicated than the product rule, right? And in order to remember this, it is nice. There's I've heard this little, I don't know, rhyme sort of thing to help us remember this. So it goes low d high minus high d low all over low squared. So then there's some secret multiplication going on here. So the low function, g, that's the one that you leave alone, d high. D is like the derivative, right? The derivative of the high function, the top function, the numerator function. Minus high, right? Leave that one alone, f of x. D low, derivative of the low function here, right? All divided by low squared. And one reason that this is very nifty and very useful is because you won't always have your top function being f and your bottom function being g. For instance, here, the last problem, we want to find the derivative of h here, and you can see now your top function's g and your bottom function is 1 plus f, right? So in this case, we can't just use this formula for f's and g's because f is no longer in the numerator and g is no longer in the denominator, right? They kind of got switched and stuff like this. So really, you need to be thinking about this as derivatives of the numerator, derivatives of the denominator, stuff like this. But we'll get to that in just a second. Let's practice using this. Well, actually, even before that, again, I have a warning, right? Just like before, the derivative of a quotient of two functions, right? One function divided by another function, is not equal to the derivative of the top function divided by the derivative of the bottom function, right? You cannot just distribute this little prime to the top and the bottom. That really, really, really super, super duper does not work. Very, very much not equal. And so the little mini example here that I have, so if you have x squared divided by x, well, we know one thing we could do is just simplify that down. We would have, that's just x, and so if I took its derivative, I'd get 1. That's fine. And yet, if you tried to distribute that prime, right, if you were to try to do x squared prime and x prime, so take the derivative of each one of these things, well, you get 2x on top and you get 1 on bottom, and so you'd end up with 2x. 1 is definitely not equal to 2x, right? This is a constant function. This is a linear function. They're just certainly not equal. This in no way is true, but I see this mistake quite often, so I want to warn you guys about it. Please, please, please remember the quotient rule. Okay, let's go ahead and practice then. Use the quotient rule to calculate out derivatives of some functions. So here's my top function, my bottom function. So let's apply the quotient rule here. So the derivative is equal to, so the derivative of the top, right? So this is going to be 2x, right? That's the derivative of x squared plus 1, 2x, times the bottom, leave that alone, minus the top times the derivative of the bottom. Now the derivative of 3x minus 5 is going to be 3. All divided by the bottom squared. 3x minus 5, quantity squared. Again, I would not spend a lot of time simplifying this. This is how I would submit my answer. This is what I would give 100% for. Okay, let's try it again. Part B, it looks like something fancy should cancel. Unfortunately, it really doesn't. You can see we have some square roots, so I'm going to remind ourselves one last time here. If you want to take the derivative of the square root of t, right, it's very good to remember that the square root is the same thing as t to the 1/2. So you can take the derivative of t to the 1/2, and that's going to be 1/2 t to the negative 1/2. So that's an important thing to remember. We're going to definitely see this coming up here. Let's go ahead and use that. So if I want the derivative of g of t here, we're going to take the derivative of the top. So the derivative of the top, so that's going to be my 1/2 t to the negative 1/2. And the derivative of 1 is, of course, 0. So there's the derivative of the top times the bottom. Right, we leave that bottom alone. Minus the top times the derivative of the bottom. So now we're taking the derivative of the bottom. So the derivative of the bottom is, again, we're going to use this fact that we know what the derivative of the square root is, 1/2 t to the negative 1/2. And the derivative of negative 1 is 0. It's a constant. All divided by the bottom squared. And I know it's very tempting to kind of distribute the squared to each term, right, because it would help cancel out with that square root. But remember, when you have a binomial, right, two terms squared, you have to FOIL it all out. So you can't just distribute that 2 there. So again, I would not spend a lot of time simplifying. This is how I would give my final answer, right? If you simplify down, you just come up with a chance to make mistakes. This is how I would give my final answer. This is what I would give 100% for. All right, so there's the derivative of g. And like I said, here's our last problem. We don't even know what h of x is. I mean, we have this, it's supposed to be, strange. It's supposed to be the quotient of g and this 1 plus f, but f and g we only know for very specific values, right? Luckily, we can still calculate out h prime of 2, given these values, using the quotient rule. So let's get to it. First of all, I'm going to do h prime of x. So I'm going to take the derivative of the top. Derivative of the top is going to be g prime of x. Can't really do any better than that. Times the bottom, 1 plus f of x. Minus the top, leave that alone, times the derivative of the bottom. So the derivative of the bottom, well, the derivative of 1 is just 0. And the derivative of f is f prime of x. Can't do any better than that. Divided by the bottom squared. There we go. Now let's go ahead and plug in 2, right? Because I don't want h prime of x, I want h prime of 2. So I'm going to plug in a 2 everywhere I see an x. So this is going to be g prime of 2, 1 plus f of 2, minus g of 2 times f prime of 2, all divided by 1 plus f of 2 quantity squared. So we know, for instance, what g prime of 2 is. Let me use a different color here. G prime of 2 is given to me right here. We know it's 7. So I'm going to substitute that, 7. We know also f of 2, right? F of 2 is supposed to be 1. So I can do 1 plus another 1. That's going to be 2. So this is 7 times 2. Minus g of 2. G of 2 is given to us as well. It's 4. So 4 times f prime of 2. Running out of colors now. Pink. F prime of 2 is given to us right here, negative 3. All divided by 1 plus f of 2. We've already used f of 2 up here. It was 1, right? 1. So 1 plus 1 was 2. 2. And that's supposed to be all squared here. And so I get 14, right? 2 times 7 minus, let's see, 4 times negative 3 would be negative 12. So minus a negative 12, that's going to be plus 12. All divided by 2 squared, that's going to be 4. So I'm going to get 26 divided by 4. We can throw this into our calculators if we'd like. It's going to be 13 halves, or that's going to be the same thing as 6.5 Yeah, there we go. So for full credit, I'd say right here is a good one, or 6.5, of course, if you want to throw that into your calculator. But you can see this one's kind of clever. There's not a great way to use our calculator to check this or anything like that. We just really, really have to know what is the quotient rule. All right, that's going to be the end of section 3. I'm going to see you guys here next time in section 4. See you then.